Hello everyone, let's take a look at our next problem. So this one is submitted by a viewer again. 3 people have a small secret number, an integer between 1 and 1,000. Everyone wants to know the sum of these 3 numbers, but they want to transfer the data so that no one knows someone else's number. Make an algorithm to make sure that everyone will know the sum and will not be able to find out someone else's secret number. Okay, so this is a cool problem. I have seen this before, and I know the answer. At least I think this is the exact same problem that I've heard of. If I had not seen this before, I'm really not sure what my first approach would be. But as soon as I started reading the question, I was pretty sure that this is the problem I'd seen before. Let me just make sure. Yeah, okay. So I'm sure there are other solutions to this. It doesn't matter that it doesn't matter that there are 3 people. It doesn't matter that it doesn't matter that they are integers between 1 and 1,000. This will work in a much more general setting. But here's the idea. So let's call the 3 numbers that the people have n1, n2, and n3. And in some sense, they sort of play a game of broken telephone. So person 1 starts, and person 1 creates a new number. Let's call it n1 plus z1, where z1 is random. So choose any distribution which has sufficient metrics of randomness, large variance, whatever you want. They're going to take their secret number and add this take a single random draw out of a hat of this from some distribution, call it Z1. And we'll call this M1, where M1 stands for message. What they're going to do is pass M1 to person 2. So person 2 receives the message M1 from person 1. And then person 2 will take M2 and add to it their own number plus Z2, where Z2 is again a completely random number chosen from an arbitrary distribution that doesn't have any kind of information in it. And then we do the same thing. M2 gets passed from person 2 to person 3. So now person 3 knows the value of M2, and they set M3 equal to M2 plus N3 plus Z3, where again N3 is their own private number, Z3 is some randomly generated number. And now once we have M3 gets passed from person 3 back to person 1. And we create a new message. We'll call it M1 prime. This is going to be equal to M3 minus Z1. So person 1 has to remember the randomly generated number that they added to their original private number. And they create a new message, which is M3 minus Z1, ... M2 prime is equal to M1 prime minus Z2, and ... M3 prime is equal to M2 prime minus Z3. So basically the idea here is each player takes their own private secret number and adds some kind of random noise to it, and then they pass along a noisy value of their private information. And they add those 3 things up in the first 3 steps of the problem. But then on the second pass through the messaging between the 3 players, they subtract the noise that they originally added to their private signal, And so at the end, M3 prime happens to be equal to N1 plus N2 plus N3. So the third player, once they receive this M2 prime, they subtract the original noisy component to their original message, and the result will be the sum of the three numbers. So then player 3 can announce to the other two players what this sum is. But because everyone always received a noisy piece of information, nobody actually knows anybody's secret number except themselves. So like I said, I've seen this problem before. It's a really cool problem. It's a great, party problem to talk about or give to friends. I don't remember where I heard this for the first time. Probably in some kind of situation where I was with a bunch of friends and we were sharing interesting problems like this. And I'm really not sure where I would have started or what my first instinct would have been if I hadn't seen the solution to this one already. Very cool problem. Thanks for the submission. If I have any additional thoughts on this, check the description. Otherwise, thanks for watching.